Hello and welcome everyone to our final session, learning from experts on applying complexity methodologies of research. And a fun thing, we've been recording and then uploading all of our videos to our YouTube page, which you can find here in the chat, just linked it for you. And my name is Joey Eisman. I am a doctoral student at Temple University and the graduate student representative for the Complexity Theories in Education SIG. And the purpose of the SIG is to apply, advance, and extend complexity theories to inquiry, research, theory, and practice in a variety of educational contexts. I am pleased to be joined by Dr. Emma Bullock. Dr. Bullock is an assistant professor of mathematics education in the Mathematics and Statistics Department, College of Science and Engineering at Sam Houston State University in Huntsville, SHSU, Texas, just north of Houston. She researches the design of and teaches use of digital math tools and other visual mathematics representations, and studies the intersection between student mathematics achievement and school leadership, modeling schools as complex adaptive systems. In particular, she focuses on visualizations of complex adaptive systems and mixed methods research, study, and design. At SHSU, she teaches undergraduate mathematics and pre-service teacher mathematics content courses and graduate mathematics courses, and enjoys mentoring and working with both undergraduate and graduate students in all aspects of her research, teaching, and service. She currently serves as the incoming president of the Southwest Education Research Association, on the boards of the Mixed Methods International Research Association and SHSU Charter Schools, and as the editor of the Journal of Mathematics Teacher Education in Texas. A majority of our session will include Dr. Bullock's presentation. If you have any questions, please post them in the Jamboard linked in the chat. It just popped in for you. And we will share them with Dr. Bullock as time allows. Please join me in welcoming Dr. Bullock.
Well, thank you. I appreciate that introduction. Well, welcome to this presentation on complexity-informed mixed methods data collection procedures, specifically focused on visualization as a tool for developing instruments and protocols. Before I jump into that, lately my interests in complexity theory have really focused on how to make complexity-informed educational research methods, and subsequently how those study results are reported to the broader public more accessible, applicable, and acceptable to educational researchers, granting institutions, practitioners, and policymakers. I think most of you are here because you've already bought into complexity and feel that it is a paradigm that deserves to be utilized. However, many of you have probably come into contact with more than one colleague or granting institution or publication that finds complexity to be difficult and hard and don't know really how to make sense of it. And so my area of current research is on how to make complexity more accessible so more people understand how cool it is and want to use it. So that leads into my agenda here. And when I say why educational complex adaptive systems, I'm not saying that to convince any of you, but to possibly give us some arguments for how to convince others. And so within that kind of 4 big points, the need for a complex systems approach, it's really about equity. When we start talking about equity and how complexity can help us to research in more equitable ways, people start to listen a little bit more. Then I want to present a conceptual framework that I'm then going to build on to deal with the pressing issue of data oversimplification and what the implications of data oversimplification are for equity, and kind of talk about how data oversimplification can occur. And the purpose of that is to start to give us some language to help us justify to those that we come into contact with the need for complexity and why it's important. Then I know we've had a number of webinars, which I've really enjoyed, that deal with analytical procedures and ways of visualizing our results, which I think are super needed and great. My presentation today is really more about the beginning of the research design process. and how we design that research in such a way that it's understandable and justifiable to others as to why it needs to be that way. And so I'm going to describe an iterative process involving visualizations of complex adaptive systems and introduce some language that my colleague and I have recently published or have under review to help us be able to talk about the need for these kinds of data sources and thinking about how we're collecting data when researching complex adaptive systems. And so that verbiage has to do with talking about first, second, third, fourth, fifth ordered level influences. And then I want to provide some examples and how to use this process as a tool for developing instruments and protocols. And hopefully by the end of this, you see that a lot of the data sources or being able to more equitably include diverse perspectives kind of lends itself to the need for mixed methods approaches. So let's jump into why educational complex adaptive systems. So I'll just talk about what's in the news right now. I don't know how many of you follow Houston Independent School District news, but it's one of the largest school districts in the United States of America and the largest school district in the state of Texas. And in the news today, I've got a couple of links here, but just kind of talks about the Texas Education Agency is taking over Houston Independent School District. And the reason I pull up this article to share with you is, I was literally reading this in the newspaper 2 days ago, and someone made the case that it's estimated that teachers account for about 10% of the variance in standardized achievement test scores, while out of school factors account for 60%, right? And you know, of course, there's this little link here. So I'm like, oh, I want to see where they're getting those numbers, right? So then I come over here and you've got this blog that's talking about research from David Berlinger, who's out of Arizona State University. And he talks about how most research uses school level demographic variables such as race, gender, and degree of economic disadvantage. But then he talks about how in his research, you know, there was all these other kinds of variables, like whether the child was preterm or low birth weight, or whether they had high lead exposure or never been homeless, or had a mother with less than a high school degree. In other words, as I'm sure you are all convinced, there are a lot of variables at play in a system such as the Houston Independent School District. But here we have a real life example of how a school district is being taken over by the state because of looking at a few variables and then making decisions over that. And we have made, I published a little editorial in 2022, where I talked about how struggles over the last century to improve equity in school systems are hindered through inquiry practices that seek to reduce or even ignore complexity. And so when we think about that, then we would think, oh yeah, then we should definitely include complexity. But as you all know, complexity is hard. It's not just hard for us researchers who are trying to design studies and explain our results clearly and get funding, but it's really hard for practitioners to wrap their heads around what sometimes we're trying to present to them, right? So if we really want a complexity lens to be able to advance and get out there so that people embrace that lens, which I think is an equity issue, we need to have ways to justify why we need this lens versus another lens, and why we need to engage in this super hard work. So I'm going to try to make a case for how we can do that at the outset of a study when we're designing it. So I I just published, just had this visualization get published in January of 2023. And actually, I don't think this is super original, to be honest. This kind of shows the nestedness of complex adaptive systems that we've all seen variations of for many years. Now, to those who are new to complexity, of course, this kind of visualization is a great starting place. We need a place to be able to talk about how we could have different possible units of analyses. It could be someone here at the individual level, or we could have a unit of analysis that's at the group level, that's made up of individuals, independent agents that are simple, self-organized local relationships and all of that. I'm kind of going through this quickly because you guys are all in this vein already. And then we can see, oh, our unit of analysis, though, could be a collection of groups that we want to look at. And then we have our feedback loops and emergence and complex adaptive behavior. And this is all really important to just start to begin to wrap our heads around what a complex adaptive system looks like with different levels and influences and that sort of thing. But if we stop right here, if this is the only visualization that we use, it doesn't help us get into the weeds of how do we design studies that are capturing all of this complexity. And so my colleague and I, Cheryl Poth, we really have been focused on taking this image and going further and getting more explicit with how we can use this. And the reason why is because of this pressing issue of what we are naming data oversimplification and its implications for equity. And this is actually an article that we have under review right now. We actually did a big fat literature review trying to find anywhere that people had talked about data oversimplification and couldn't really find an operational definition. So in our paper that's under review, we are operationally defining data oversimplification as involving the conscious or unconscious act of reducing the complexity of data collection plans to such an extent that an excessively distorted view of the contexts of a research setting is given. And being able to define that is important because we need language in which to be able to communicate with people as to why we need to look at 30 or 100 or more than that variables and why that could matter in our complex adaptive system. I actually had a conversation with an NSF director recently where I was discussing with him my research plans of looking at this in a complex way, and he said, sounds like you're throwing the kitchen sink at this. And I said, well, if we really want to understand all the different kinds of influences at play, then we have to recognize that perhaps we unconsciously don't know all the variables at play yet. And for us to start with the biased assumption, I think, that we understand all the variables at play to begin with could lead us to miss some important factors and thus unconsciously present an excessively distorted view of the context of a research setting. And the hazard of data oversimplification, with its important implications for equity, is that then our study inferences may not lead to impactful policy or practices. If in our data collection, the data that we've collected is so simplified, then trying to draw conclusions about that data on a very complex situation is really not justifiable. So how can data oversimplification occur? There are 4 different ways that we identified as how it can occur. And perhaps there are other ways. Like I said, we are in the weeds right now, trying to make this very accessible and understandable. The first way that we felt data oversimplification could occur is not recognizing or even ignoring the complex structure of the problem. And that goes back to nestedness within and across organizational levels. That's where that first visualization, I think, starts to get people to recognize that there is a complex structure. The second way is we could fail to identify, consider, or understand the strength of relevant influences, either direct or indirect, on the unit of analysis. So not only do we need to understand nestedness across organizational levels, but we also need to understand how different influences are impacting the unit of analysis, and they may not always be direct influences. The third way data oversimplification can occur is by not collecting data from relevant sources or samples, thus leaving out important perspectives and voices essentially needed to understand the problem. And I think in the educational academic world, we're recognizing more and more and more the importance of including diverse perspectives, marginalized perspectives that are often left out, either consciously or unconsciously. There are voices that sometimes we leave out and we didn't even know that we needed to have them in. And so, and then data oversimplification occurs. And then the last one is failing to collect perspectives over time that capture the consequences of feedback loops. That fourth one is not so hard to resolve if you do longitudinal studies. So for the purposes of this presentation, I'm kind of focusing on the first three of these and talking about how we can avoid the hazards associated with data oversimplification. So to begin this journey that we're going to go on with a bunch of pictures, I'm going to start with going back to that conceptual framework that I started with, and I'm filling it in using the example of closing achievement gaps in urban secondary mathematics settings. Okay, so this is a problem that people have grappled with since there were cities. And so the first place we can start is by situating, okay, where's our unit of analysis? What are we interested in? And so I think you guys all can see that we would be focused on the student as the unit of analysis. And then we have a variety of other students, teachers that could be independent agents here and that make up a student's mathematics class. And then we have all these mathematics classes that are inside of a student's school. So that part is, I think, a part that our field so far does good at being able to articulate or visualize. But now we want to take this starting point and rigorously justify what kinds of influences should we maybe be considering in our research designs. So that's where we come to this iterative process that I'm about to introduce, involved in visualizing complex adaptive systems. And it basically comes down to three iterative processes: situating, illustrating, and capturing influences. So I want to start by just explaining this visualization. So if we're at the beginning of trying to design a research study involving an educational complex adaptive system, then we want to really think through carefully and understand the complexity-informed data sources and sampling. And I'm going to get to the mixed methods design situation in a second, but we want to understand what are the data sources and sampling that are needed so that we are understanding the complexity of our system and we're not oversimplifying the situation. And so we have these three processes: situating the unit of analysis, illustrating nested levels, and capturing influences within and across the levels. But then the question is, well, how do I do those three processes? And so that's where we came up with three strategies specifically to address oversimplification hazards that help us to engage in these processes. So strategy one overlaps and contains both situating the unit of analysis and capturing influences. And strategy 1 is where we identify what the unit of analysis actually is that we're interested in. And then we begin brainstorming influences on that unit of analysis. And by doing that, we address the hazard of failing to recognize relevant influences. Strategy 2, which helps us to deal iteratively with situating the unit of analysis and illustrating nested levels, is where we visually situate the unit of analysis itself within the nested levels, and then we brainstorm data sources of where we could get information about these influences that we started to brainstorm. And that helps us to deal with the oversimplification hazard of ignorance of the complex problem structure. The third strategy iteratively helps us deal with capturing influences within and across levels and illustrating nested levels. And I'm going to show you an example coming up. Strategies 1 and 2 and how the visualizations that are used in doing that. But then we take the visualizations from strategy 1 and 2. And in strategy 3, we apply those visualizations of influences within and across nested levels and brainstorm further data sources and sampling. And then we often do that with a table. And so I'm going to show you examples of tables that helped us to capture information about influences, data sources, and possible sampling populations. And what this strategy does is it helps us to deal with the oversimplification hazard of lack of data collection to address the research problem. So as we're going through this visualization process, I now need to introduce some, I don't know that it's brand new, but maybe in the ways I'm using it is new, where we actually name different, what I'm calling first order, second order, third order influences, and provide definitions of what they are, so that we can explicitly think through what those types of influences look like. So remember I was talking about our example of closing achievement gaps in urban settings. Okay, we're going to continue to use that as our example. So first order influences are the easiest ones for us to do, because guess what? They represent the types of data typically collected across any kind of study. Everybody collects first order influence data, regardless almost of the paradigm in which they are operating. So what first order influences are, the way that I am defining them, is these are influences internal to our unit of analysis. So while first order influences can dynamically change over time, they are measured at the uniquely individual level. These are not emergent properties, but parts of the whole, which may then lead to emergent group properties at higher nested levels. So when we were thinking about our unit of analysis for closing achievement gaps in urban settings, we thought of a student. And by the way, you are seeing the final visualization. I'm doing a shameless plug here, doing a whole workshop next week at AERA where we're actually going to get actually start drawing, and they're all going to be messy. But I mean, I don't know if you can see me. I have pages and pages and pages of hand-drawn pictures that were revised and revised and revised and revised before we got to this final picture. Okay. But as you can see, some first order influences on an individual student could include their health, their mindset, gender, sexuality, economic status, race, ethnicity, special education status, English as a second language status, all the normal things, lots of other things. Also, like, since we're talking about mathematics, like what class are they in? What grade are they in? And, you know, sometimes those classes like Algebra 2, that they could have 9th graders, 10th graders, 11th graders, 12th graders, all in one class, right? So this picture represents the result, the visualization of strategy 1 and strategy 2, where we were brainstorming influences and possible data sources. And now we're going to, in strategy 3, we're going to take that visualization and use it as a way to list the innate influences on our unit of analysis, which in this case is the individual student. Then we want to talk about possible data sources to collect information about those influences. And then we want to talk about possible sampling populations where we would implement those possible data sources to collect information on those influences. And so a lot of these are really familiar: demographics, health, mindset, achievement, utilize student resources. Here are some possible data sources: surveys, past courses, grades, attendance records, and here's some different sampling populations. Probably unsurprisingly, students, since they are our unit of analysis, would be sampling populations for all of these to be able to get information about them. Strangely, though, we did a really extensive literature review looking at specifically studies that were analyzing how to close achievement gaps in urban settings. Every single one of them did not actually ask a student a thing. They collected information from data systems about students, but never actually involved students themselves in collecting any data about their first order influences. Okay, so second order influences. So what second order influences are, is they are immediate, direct, external influences on the unit of analysis. And they impact the unit of analysis on a near daily basis. And they can be visualized as the first group level made up of individuals. So some possible second order influences. So just so that you can make the connection, here's that little person, right? So that little person is the same person over here in our first order influence visualization. So that little person has all those first order influences influencing them internally. Then externally and directly, they have all these other influences: friend groups, family group, religious groups, political, civic groups, extracurricular hobby groups. Depending on your context, you may come up with different things, but these are possible influences. And then you take all of those individuals' units of analysis with both their internal first order and their external second order influences, and you have a collection of these that make up a class, along with, in a different color, the teacher, because the teacher has their own internal first order influences and their own external second order influences. And all of those together make up our first group level, in this case, a classroom. So we take that visualization and we come up with a bunch of immediate direct external influences on our unit of analysis, which in this case is the individual student. And these are a lot of very different influences than I have ever seen in my field be talking about mathematics education, okay? So we have classroom teacher demographics, teacher health, teacher mindset, teacher outside obligations, instructional activities, classroom management, culture demographics, class achievement, family demographics. Now you may say, I've seen studies that have those influences, but they generally maybe they're looking at the teacher as the unit of analysis, in which case some of these would then be first order influences. Remember, we're talking about in relationship to our unit of analysis. So influences may change whether they're first or second or third, depending on what our unit of analysis is. And that's why thinking really carefully about that is important. And then we can come up with a whole bunch of possible data sources of how we could collect data about these types of influences. And then we can think about where would we go to get that information? And that's what our table helps us to see over here, is sampling populations that could give us information about these second order influences. Okay, third order influences. Sorry to go through this really quickly, but we're going to bring it all back together. So third order influences. Third order influences are less immediate, direct or indirect external influences on the unit of analysis. They impact the unit of analysis on a regular but not necessarily daily basis. And they can be visualized as the first group level made up of individual groups. So, with respect to our unit of analysis. So once again, just so that we can kind of see how these are all connected, right? Here's our first order influences that are represented in here. Here's the second order influences. In this case, this is referencing the parents because they had first and second order influences on them as well. And then we have, you know, school leaders, teachers, students, parents. There could be others inside of this school as well. But then those groups are all interacting and influencing each other. And so we can come up with third order influences. So using this visualization, we're able to come up with influences on the individual student. They may be indirect influences, but they're still influencing at some level. And so we're able to come up with a lot more possible influences that may or may not be important. The idea here is I'm trying to leave myself open to exploring influences that maybe I'm unconsciously not sure actually, I just don't know are important or not. And then we get some possible data sources. We get sampling populations at that third order. All right, fourth order influences. And by the way, the number of ordered influences will depend on your context, right? So there could be more or less depending on what your unit of analysis is, where you're starting with this, and what the context is that you're looking at. In our particular case, a fourth order influence would be an indirect external influence on the unit of analysis through their influences on groups in which the unit of analysis belongs. In other words, these influences are influencing the groups that our unit of analysis in, not necessarily directly onto to our individual student itself. And so we think of them as being external to second and third order influences, and they impact the unit of analysis on a regular but not necessarily daily basis. So again, think over here, there's our little individual student in red, and it's got first order influences, and you got your second order influences, you have your third order influences here in your school, and then all these schools together, along with a district office, which include district math, support staff, superintendents, they all make up that district. And in this way, we're able to use this visualization to think about fourth order influences that could be impacting our unit of analysis. We can come up with possible data sources and possible sampling populations. All right, I'm going to condense the 5th through 7th. So 5th through 7th order influences in the case of closing achievement gaps in urban settings for mathematics. These are indirect external influences on groups to which the unit of analysis belong. And these influences are really felt more at the policy or support to third, fourth level influences aspect. And the number of these, like I said, can vary based on the context of your complex adaptive system. So remember, there's our little red student in there who represents our first and second order influences, the third order influences, the fourth order influences. Now, in the state of Texas, so this could be totally different for other states, okay? But in the state of Texas, there's a regional system. Texas is so large, it divides it divides the state into 20 regions, and so all the districts within that region work with a regional educational center. And so in the state of Texas, that regional level is important, and it's going to be providing a lot of teacher supports and school leader supports and district leader supports. And so that's going to have its own set of possible influences that could be indirectly impacting an individual student. And then, of course, you have these 20 regions inside the state of Texas, and you have the state of Texas inside the country of the United States of America. And so there are some 6th order and 7th order demographics. Now, at this point, you may be saying, there is no way I am ever on God's green earth going to conduct a study that contains all of these influences. And I am not suggesting that you have to. But what I am suggesting is that we need to be able to justify, if we want to truly conduct research with a complexity lens, that we are collecting the data we need that captures the influences that are relevant to our complex adaptive system and the question that we're interested in. Without going through this sort of a process, because we're dealing with complex systems, I think it's fair to say we're going to underestimate the complexity of the data collection plans we need, and we're going to fall into the hazard of data oversimplification. So going through this process can be a way for you to justify which of these influences do I really need to include and which do I not, and why do I need to be looking at these different levels. I think that's really, really important. Okay, so that seems like a lot of work, and it was, but like I said, working in complexity is hard, right? So now let's say we've gone through this whole process, we've done these visualizations, we've come up with these lists of possible influences. How do we, remember, I want to get into the weeds. I want to get into how do we do it? So how do we use those as a tool for developing instruments and protocols that purposefully and thoughtfully collect data across influence levels? So if you go back, we're going to go back here. I'm just going to offer an example for the sake of time. I could offer more examples, but for the sake of time, I'm just going to do one. Come to the workshop, we'll do more. So let's say we wanted to develop a survey for students, okay, that help us to capture important data about various influences. So what we can do is we can come over here and we can look, oh, students, and I think this is natural, could help us to collect pretty much like every type of information about first order influences. They could help us to gather information on that from their perspective, right? Then if we look at our second order influences, we go, right here, students could be a good place for us to gather information about classroom management or culture. They could also give us maybe some information about their class achievement. Also, they could give us some information about their family dynamics and that sort of thing. And I've got lists of possible things that you could ask them about here. In looking at third order influences, we can see students are a possible population to gather information about school management and culture. And for fourth order influences, we see students might be someone who have a perspective on district management and culture. But once we get to fifth through seventh order influences, they're so far removed from the individual students' direct influences that we can see that really they're not a good place to be sampling for that kind of information. So what we can do is we can use that to go, okay, I want to collect information from students about these first order influences and about this second order, these types of second order influences and these types of third order influences and these types of fourth order influences. Now what I'm going to do is I'm going to in this slideshow, and I'm going to pull up an example of a survey that does this. Okay, Joey, can everybody see this survey? I'm going to blow it up here. Okay, so again, this is a sample. Yours may look different, right? Depending on how you analyze this. But here we've got, and I'll just show you, this survey is not that long. You might say to yourself, it's got 15 questions with some side questions, okay? But sometimes we think, oh man, the survey that I designed is going to now be an hour and a half and no student is ever going to take this survey, right? It doesn't have to be like that if we're really careful and purposeful in justifying why we're including things on our survey, or items on our survey. So we have some first ordered influences here: gender, race, sexuality, religion. Do I get enough to eat every day? Do I exercise regularly? Information possibly about physical or mental illnesses or disabilities. But already we're capturing quite a bit more information, even on first order influences, than we typically get in most studies that are just looking at race, ethnicity, gender, English as a second language. Please indicate the extracurricular activities or hobbies that you regularly participate in outside of regular school hours. Give them some possible examples: football, crocheting, painting, playing the piano, volunteering, etc. Remember, we said mindset could be an important thing to capture information on. So when you think about mathematics, which of the following most closely matches your perceptions? And you could set them up with pre-programmed answers so that it's not, or you could leave them open. Okay, you could decide like how, if it's important for you to leave it open or and collect free responses, or if you want to provide them, or you could even give them an other where it says, tell me something else. Then we had some information about, you know, their achievement, their attendance, and how they utilize resources. So here's some statements that they could select that may or may not describe them. Now we want to get into some of these second order influences. When you think about mathematics in school, who do you think has had some influence on your perceptions up to this point? You could do a Likert scale, very strong to no influence. Notice here that I've included the school police officer on this list. I don't know about where you live, but where I live, all of the districts have their own police departments. They don't just have like, the Houston ISD has a Houston ISD police department. And so that could be part of those influences, right? Anyone who had a very strong influence that was not listed. When you think about mathematics in your school, please indicate what was helpful or not helpful, meaning it hindered your ability to do well on you being successful in mathematics. Teachers, classmates, athletics, music, art, debate, student interest groups, coaches. Lots of different people that are not typically included in studies designed to look at these hugely complex systems. Was there anything else not listed that was very helpful? Was there anything else not listed that was not helpful? So you can see I used my visualizations. Let me go back to this here. I don't want to go here. I used my visualizations to purposefully, to purposefully design my survey to capture specific ordered influences. In this way, we can justify to funders and we can justify to publishers and to journals why we are including the factors that we're including in a way I think that is understandable. So here are my references. Another shameless plug to come to our workshop next week, where we're going to have enough time to actually allow people to bring their own study context and do their own visualizations and get messy. And we're going to have markers and paper and all the fun things. Bring your laptops. Thank you. Thank you for coming. Happy to answer questions.
Thank you, sir. Thank you very much, Dr. Bullock. If you stop sharing your screen for a moment, I'll happily share my screen to anyone who wants. We still can. Feel free to drop any of your questions into, if you want, into the chat, but I'm also happy to put them into the Jamboard. There are a bunch of questions I've been asked. Feel free to pick and choose as you will.
Thoughts about standardized tests for assessments. I think that they are an important part of the complex adaptive system. So because I mean, I know particularly in Texas, standardized systems drive instructional choices. They influence heavily the decisions that school leaders make about personnel and where to place them. And so while I am the first person that will tell you that as far as mathematics content knowledge goes, it is not a great assessment of student mathematical knowledge or learning generally. When you're trying to understand a complex adaptive system, they are very important to include, in my opinion. Regarding your equity comments, do you believe that by definition, complexity theories are critical theories, or do we need to update, reimagine our paradigms? Ooh, that's a great question. I believe that they could be a subset of critical theories. Yes, I think that is a possibility. Do I actually have that all worked out in my brain? No. But I think that could be something that could be explored in a way that could make complexity theories more accessible to those who live in the critical theoretical realm. How does the order influences in the system relate to Bronfenbrenner's ecological system? I would like to say that I am familiar with Bronfenbrenner's and if I'm butchering that, I apologize, ecological system, but I am not. And so I will not pretend that I know that. But now I have a good person to go look up and compare to. So thank you for bringing that to my attention. Is there a way to identify influences that are more data-driven than relying on our own brainstorming? Absolutely. I think because this is an iterative process, and I think that engaging in complexity-informed research is a complex process itself. In the recent papers that we've published, we've talked about the need to, throughout your longitudinal study, continuously go back and reassess what influences, like we were unconsciously leaving out at the beginning of our brainstorming processes. So we always need a place to start, right? But we definitely need to acknowledge that our own brainstorming processes are not going to probably be completely correct, right? So as we get into studying our complex adaptive system, we're going to learn from our data about some influences that we have inadvertently left off and now need to include. Am I answering? By the way, people are throwing these things up and I'm just answering away, but on the ones I've answered so far, does anybody have a rebuttal, something else they want to add?
If people want, you're more than welcome to take yourself off mute if you want to ask a follow-up, if that was or was not your question. But otherwise, Dr. Bullock, please continue.
Okay. Okay, you tell me if, yeah, okay. I'm wondering what kinds of apps or website you use for visualizations. Yours seems very cool. Okay, I'm going to be super, super transparent here. So let's see. I'm gonna, like, this is how they started. Okay. Ta-da, like, and then I pay for a graphic designer. So I take my handwritten drawings and I send them to my graphic designer and I say, make these understandable. And then she comes back because that's her area of expertise with these ideas. And then we have this iterative process where we go back and forth, back and forth, back and forth until we're getting to the visualizations that seem to capture what we intend them to capture. With the understanding that I have to go back to her after we started the study and update those visualizations as we get into the data and recognize there are some influences we've left off. Is CAS a theoretical framework or can it be implemented as technological? Well, I mean, honestly, if I'm being more careful with my language, complexity theory is the theory, right? So, and that can be applied in a variety of complex systems situations. Complex adaptive systems are one type of complex system, not the only one. So really, it's more of a conceptual framework. I should have been more careful of applying that theoretical lens. If I'm sure there are people here that are just jumping at the bit to say the way you said that is not what I agree with, but that's how I made sense of it in my mind. Thoughts on visualizing HLM? No political discussions. Yeah, probably better. Thoughts on visualizing HLM models? I would love to explore that. I have not yet. So that could be a next great place to go to think about that. Like I said, I've been living in this world of trying to make this more accessible for about 2 years now, and there's a lot more work to be done in that realm. And so I invite all of you to come and join me. Why do you assume that some, at least, of those order parameters are not emergent properties? For example, aren't mindset emergent? You know, we could probably have a discussion about that, right? Because you do have feedback loops and you do have people that are dynamically changing their mindset internally. I think the reason, I might have to have a whole philosophical discussion that's going to take more than 3 or 4 minutes, but I think the reason I said I don't think of those as emergent properties is because I was thinking that as more of a group level, like describing some kind of a group level property that cannot exist at the individual level. So that's kind of why I was thinking of emergent properties, that they are a property that you can't measure unless you have groups or individuals interacting with one another. So that's kind of been my understanding of an emergent property, but not everyone may agree with me there. Some people may think that emergence just means that there's feedback loops involved. And I've kind of always thought of emergence as you need agents interacting with each other to be able to create an emergent property. So I don't know, we could have that would be a great one to go to lunch and process. I could change my mind on that. Why is it called CAS? Is it because there's an adaptive nature to the framework? Well, the complex adaptive system, I think, was really referring more to the fact that our system is ever changing and never static. I wasn't really thinking of applying it to the conceptual framework. I was thinking more of like iterative as being that word that talked about how things are continuously changing through that nature to the work. But in some of our papers, we did use adaptive processes. We did use the word adaptive research designs to talk about the fact that that our research design is adapting as we learn more and more and more about what the structure of our complex system actually is. So I think in this context, I wasn't thinking about it in that way, but I think in other contexts, I think you can, I was thinking, you can think about it in that way. Do you have any guidelines for knowing how many levels are enough? You know, I think, I know for us, we stopped at 7 because that seemed like a natural boundary spot, right? In the United States of America, there's a certain culture towards education that kind of embodies like the boundary of that system, at least in the context of understanding how to close achievement gaps in urban mathematics settings. If I had a different research question or topic I was interested in, it may be that I went globally, but it didn't seem like a natural place to stop. So my answer is, when you start, you eventually have to find a stopping point that seems natural. But in going back to the data-driven rather than relying on our brainstorming, it is possible that as you get into the messiness of this work, you decide to get rid of a level or add a level as you come to understand the contexts better of the system that you're studying, if that makes sense. So I guess my answer is start somewhere and then see where the journey takes you. That's so not, that's so kind of vague, and I'm sorry. I think that's all of them. Any other questions?
Do we get to the, how would you handle feedback across levels?
Oh, where was that one? Sorry.
Right here.
Oh, sorry. Okay, how would you handle feedback across levels? Yeah, so that's why number 4 for data oversimplification was so important. The need for a longitudinal type kind of study that captures feedback loops over time, being able to see how the system changes in response to, you know, how school leaders and district leaders and teachers and students and parents all react to decisions that are made based on that achievement. Yeah, doing a study for 1 year is not really going to be able to help you capture that.
Wonderful. Thank you so much. First of all, please join me once again in thanking Dr. Bullock for leading us today. Thank you so much. Snaps, claps. And if you want, you can see, as Dr. Bullock was saying, I believe it's Friday, April 14th, is the session. So if you have any questions or comments and you want to talk to Dr. Bullock in person, if you're going to ARA's annual meeting, we hope to see you there.
Yeah, the 14th at 9:50.
9:50 a.m. Come join us. And for those of you who are joining, please take a look at our one-pager of the SIG's program. You can see all of the programs that we're offering, including Dr. Bullock's session on Friday, and also a graduate student specific social event that we're co-hosting with the Motivation SIG, the Teaching Educational Psychology SIG, and Division C. So feel free to snap that QR code. Thank you again, Dr. Bullock. Thank you for everyone who's joined us today, and we hope to see you in Chicago real soon.
That's true. All the cool people will be there.